So good afternoon, students. This is only to guide you, like the JEE Main exam is going on. So those who have not yet appeared in this July attempt of the JEE Main exam, this is just a general guidance for them that in this time of revision, what you can revise for the tomorrow paper, for the day after tomorrow paper, or after that, so that you can relatively score best from your capacity. Like, I know that you must be very well prepared. So after all that preparation, is still how your score can be maximized. It is only to guide you about that, and specifically here it's for the subject of physics. So see, in the physics, there are few parts from the 12th part which are very scoring. Starting from the wave optics up to the end of the 12th part. Because in the wave optics, the questions usually don't have much variation. Usually the questions are based upon what? Either YDSE or the diffraction pattern, or sometimes the question of resolving power has also been asked. So you just understand the YDSE very well, and then what are the different formulas in the diffraction. There are some definitions in the diffraction, and there are some equations like the position of first maxima, the position of the second maxima, the width of the central maxima, the width of the secondary maxima, etc. Then the intensity at the central maxima, the intensity at some other maxima, etc. But the variation in the questions is, if you see the question of various years, you find there is not much variation. So the wave optics, then after the wave optics, you should know the dual nature of matter. Dual nature of matter, sometimes there is a question based upon this also. Especially I have seen very often the question being repeated what? There is a photon of wavelength lambda and there is an electron of wavelength lambda. Now you have to compare their energy. So if there is an electron of wavelength lambda, electron is a non-relativistic particle. So because electron is a non-relativistic particle, the energy of the electron will be calculated from what? From the lambda, calculate the momentum of the electron. So momentum P will be equal to what? H upon lambda. And from the momentum P, you will calculate the energy of it, that is square root of twice of mass m into P, and the value of P is what? H upon lambda. But for the photon, because photon is a relativistic particle, so for the photon the energy will be what? Hc by lambda. Usually the question based upon the dual nature is this one of the most important question. Then see the photoelectric effect. So the question of photoelectric effect is also quite simple. Means ranging from the equation H nu is equal to W plus EV or W plus KE. Like there has been one very good question in the past years, that is what? Suppose the frequency of the photons, bombarded photons, frequency of the radiation is doubled. What will happen to the kinetic energy? It will become 2 times, more than 2 times, less than 2 times. So see, when the frequency gets doubled, the left hand side H nu gets doubled, but W remains the same. So obviously the kinetic energy will be what? More than the 2 times. So there are questions based upon this. H nu is equal to W plus kinetic energy. When you apply this equation, you have to keep the units in the mind, because see, the charge of the electron, like kinetic energy K is what? E into Vs. So if you keep the charge of the electron in the coulombs, then voltage V, that should be in what? It should be in volts. Similarly, sometimes the value of W is given in the electron volts. So if you are taking all the things in the MK system, that is in the joule, you are taking all the things in the joule, then the W should also be converted into what? It should also be converted into joules. So either you can do by getting all the things in the electron volt, or you can do all the things by getting them in the joule system. Then after this equation, there have been so many questions based upon the graphs. The graph between the frequency nu and the kinetic energy. The graph between the frequency nu and the kinetic energy. So there have been various kind of graphs which have been important and the questions from which have been asked here, it is this. See, one of the graph is, this is one of the very important graph which I have seen. The question is generally repeated. It is about the photoelectric current in the voltage V. It is about the voltage V. So you see the cathode voltage and the photoelectric current I. So this is the graph for a certain intensity and certain frequency. Certain intensity and certain frequency. Now see, the intensity is increased but the frequency is not changed. The stopping potential will remain same but the saturation current will increase. So that becomes, say this is for the I2, this was for the I1, this for the I2 intensity and frequency nu, where I2 is greater than I1. Now see, if frequency is increased but the intensity is not increased, the saturation current will remain same but the stopping potential will increase. So the graph will be like this, see. It will be like this, see. So this graph is for the intensity I1 and frequency nu2. This was the frequency nu1 and here nu2 is greater than nu1. So because nu2 is greater than nu1, the frequency has increased. So the stopping potential will also increase. Then see, there's one more, then the graph for the, this is the graph for the kinetic energy Ke versus the frequency of the radiation. So see, when the frequency of radiation is equal to the threshold frequency, the kinetic energy will be what? 0. And see, the relation h nu is equal to W plus kinetic energy. That means what? Kinetic energy is equal to h nu minus W. So h becomes the slope of the graph, W is the negative intercept. So this is the negative intercept. Keep in mind the proper units. When there is a question related to the calculation, you'll have to keep in mind the units. This is for the W. This is the threshold frequency for which kinetic energy is what? 0. So this is the graph. And theta is the angle. So tan theta will be the slope, that will be equal to what? H. So similarly, you see this is the kinetic energy term. This might be the voltage V also. E into V, where V is the stopping potential. Then the graph for the voltage V will be equal to H upon E into nu minus W upon E. So in that case, the slope will give you the value of H over E and the intercept will give you the value of what? W over E. Why say I am focusing upon these parts? That even when the paper is after 2 days, or the paper is after 3 days, or the paper is after 1 day, all this what I am telling you, this can be revised in a span of around 5 to 6 hours, and this revision could be up to that level that really you can solve the question in the JEE Main paper. So that is why today, when the exams are already going on, I am insisting upon this part. So you must not leave the question of photoelectric effect. This question is generally simple. Then after the photoelectric effect, you see we have the atomic physics of atom. So in the physics of atom also, usually the questions have been that what is the radius of an electron when it revolves in a certain orbit in a certain hydrogen-like atom. So you have to remember the relation of radius. And so very often I have seen that even the radius r in what form? Radius r equals to 0.529 angstrom into n square upon z. N square upon z. Radius r generally in this form. Means what? How the 0.529 has come, this constant has come. There is no need of even knowing the whole equation also, though in some questions that has been used. So the equation of the radius, you should know what will be the velocity in a hydrogen-like atom, velocity in a certain orbit, and obviously for the angular momentum, you know nh upon 2 pi. Then you see from the velocity and radius r, you can also derive the equation for what? Time period t of the revolution, from the frequency of revolution. From the frequency of revolution, you can always find what will be the equivalent current when the electron revolves in the orbit. From the equivalent current, they can ask you what will be the magnetic field produced by the motion of the electron at the nucleus, that is at the center, and what is the angular momentum of the electron when it revolves in a certain orbit. So these parameters are very important, and very often I have seen that they usually compare the parameters for the two hydrogen-like atoms or they compare the parameters for one hydrogen-like atoms in two different orbits. So the time period T, frequency of revolution, the current I, and through that the magnetic field at the center and the magnetic moment. Similarly, the next chapter from which the question can be very easily done is the nuclear physics and the radioactivity. Usually these questions are also very easy, and they hardly need some time. Like from the nuclear physics, the radius of the nucleus, then the density of the nucleus, then the stability of the nucleus, then the nature of the nuclear force, the graph between the potential energy and the distance between the nucleons in the nucleus, and in the obviously the equation, one of the very basic equation from which there are some questions, they are based upon the mass defect. So you should know what is the mass defect, how to calculate the mass defect, and through the mass defect how to calculate the binding energy, how to calculate the binding energy per nucleon, then the relation between the binding energy and the Z, the relation between the atomic mass A and the binding energy. So that graph is very important, because from this graph, the graph of the binding energy versus A, they ask you the question related to the calculation of energy released in the fission and the fusion reaction. So what I'm telling you, please revise all those points. I'm telling you, I have seen that questions are repeatedly from this part, and the revision of this part is not at all tough. Neither the revision is tough, neither the part is so tough that you cannot understand that. It's only a matter of the fact that whether you reach up to that point or you don't reach up to that point. Then in the nuclear reaction itself, you should know that in the nuclear reaction neither the mass is conserved nor the energy is conserved. What is conserved is the energy plus mass equivalent of the energy of the left hand side is equal to the energy plus mass equivalent of the energy in the right hand side. So through this you can always find out what amount of energy will be released in a nuclear reaction. And there are some questions like that. They have to operate a nuclear power plant. They give the capacity of the nuclear power plant, that this is the capacity of the nuclear plant. They also give you the efficiency of the reaction that is being used in that nuclear power plant. They give the efficiency of that. Then they ask you that to run this power plant for so many days or for 1 year, how much fuel will be used. So what you have to calculate here is a very important kind of question, and that I have seen that it is usually repeated. What you have to see is that on one side calculate how much is the total amount of energy needed. How can you calculate that? Suppose the power plant is of P megawatt, then P into 10 to the power 6 joules per second energy is to be produced. So this is the energy per second. Calculate the energy produced per minute, calculate the energy produced per hour, calculate the energy produced per day, calculate the energy produced per year. So this is the total energy produced in 1 year if the power plant was to be run for 1 year. This is the one side of the equation. The other side of the equation will be what? The fuel that they have used, they will have given the equation for that. They must have given the equation for that what kind of equation is being used in the nuclear reaction is being used in the power plant. So from one atom of the fuel, how much energy is produced? Calculate that. Then from 1 mole, how much energy will be produced? Calculate that. 1 mole means certain number of grams. So from so many grams, this much of energy is produced. Then from say X grams, how much energy will be produced? Or from the X kg, how much energy will be produced? Calculate that. And because the efficiency is given, suppose the efficiency is 60%, then what energy is being produced from the X kg? 60% of that, you'll keep it equal to what was your left hand side. You'll get the value of what? X. So this is a very important kind of question. So that is why I told you that you must see this kind of question also. Then from the radioactivity part, you must know the basic equation of the radioactivity, like N equals to A naught e to the power minus lambda T. In the rate of reaction, R equals to R naught. R is the rate of reaction at any time. R naught is the rate of reaction at the 0 time. R equals to R naught e to the power minus lambda T. This equation. Then the equation that time T equals to 2.303 upon lambda. lambda is the decay constant into log of A upon A minus x. A is the initial activity, A minus x is the activity after time t. Then the equation of half-life 0.693 upon t half is equal to lambda, or t half is equal to 0.693 upon lambda. In the equation for the average life 1.44 t half. In one more equation, because there are sometimes the parameters is known in this form only. That is what this is, that the number of half-lives, the concentration N naught in the beginning into half to the power number of half-lives spent will be the concentration or the number of atoms after that much of time. Suppose you have 20 years, and in 20 years say the half-life is what? 2 years. So how many half-lives will be spent in 20 years? 10 half-lives. So how many number of atoms will be present after 20 years? Will be N is equal to N naught, initial number of atoms, into half into the number of half-lives, that is what? 10. Then the very important question from this part, from the radioactivity part, becomes what happens in the alpha decay? How much is the change of atomic mass, how much is the change of atomic number, and how much is the energy released? Means the equation through which you find that how much energy is released in the alpha decay. The same thing for the beta also, that what is the change in the atomic number, what is the change in the atomic mass, then how much energy is released. Means you should know how to calculate the mass defect in a alpha decay, mass defect in a beta decay, and through that to calculate that how much the energy will be released in the process. And even you should also know that in the popular alpha decay and the beta decay, what is the range of energy which are released. In the range of energy in a nuclear fission or fusion reaction also, that there is approximate range of the energy that is released in the fission and the fusion reaction. Then you know that gamma decay is followed by the alpha decay and the beta decay. In the gamma decay there is no change of mass number or no change of atomic number. So the gamma, how the gamma decay happens during the alpha decay or the beta decay, the nucleons are left into the excited state. When they get back to the ground state, the energy is released. So especially the cobalt 60 gamma decay, that's important, and you should know it with the data. You should know that decay with the data. So this is about the nuclear reaction, and see the parts which I told you. From these parts you will get nuclear physics, atomic physics of atom, the dual nature, photoelectric effect, and the wave nature and the wave optics. From this part itself you can get around 6 to 7 questions from this part only. And like when you are revising the subject matter in the last day, or when the exams is after 2 days, these 6 to 7 questions really do matter, that how you can go. And one more topic I will tell you, electromagnetic waves. In the electromagnetic waves, hardly there are, I am telling you, in all the exams, the questions that have come, there are hardly 2 or 3 kind of questions. Sometimes they give the magnitude of electric field vector, either in the vector form or in the scalar form. They ask you the magnitude of magnetic field vector in the scalar form or in the vector form. They give you the equation of the wave. Through that you have to identify the equation is either in the form of electric field vector or in the form of magnetic field vector. So to convert the equation from the electric field vector form into the magnetic field vector form, or to identify that in which direction electromagnetic wave is proceeding, or the question is based upon the Maxwell's equation, that is the modified Ampere circuital law. Modified Ampere circuital law, I mean to say about the displacement current. So you should know what is the equation for the displacement current, what is the meaning of displacement current. And I told you this part just because that this part can also be done in half an hour, and question from this part generally is not having any variety. There are 3 or 4 kind of questions that have come in the past years, and if you see the papers of even the Febuary attempt, the papers of 8 papers of the Febuary attempt, and you find out all the questions, you'll find that there are hardly 3 kind of questions from this particular part. Then see, then the next part that is important and that is simple, in which you need not to give much time, and with the revision, a small revision you can score. That is what it is, the liquid dynamics part also. Liquid dynamics part means the Archimedes law, the Archimedes law, the Bernoulli's law, the theorem of continuity, and from this part generally you have seen there is one question: Archimedes law, the theorem of continuity, the Bernoulli's theorem, and Renault number, etc. There is one question, and this question is also means the point is that like in the mechanics there are variety of questions from the electrostatics, capacitors, etc. Also there are variety of questions and there are a lot of concepts. But in these parts, even if these parts are conceptual, there are very few concepts and the applications become very limited that you can revise. I am telling you, all these parts can be revised in a very small span of time. The liquid dynamics, then after that the part of surface tension, there are hardly 2 or 3 kind of questions from the surface tension that have been asked. So the surface tension part also, and then obviously then the volume of the subject matter, after that it slightly increases, but still I'll tell you that in the physics you must revise the thermal physics part very well, the thermodynamics part very well, because generally there is one question from the thermodynamics, and that thermodynamics is very much in the chemistry also, means the laws of thermodynamics. I'm talking about laws of thermodynamics, the first law of thermodynamics, the second law of thermodynamics, the various kind of processes to calculate the delta Q, delta U and delta W in the various kind of processes through the equations or by the graph. So that's all for this session. Have a good time, very good time and very successful time. So go there with a lot of confidence and with the aim that you must solve the questions from all these parts definitely. So in the next video, I'll come up with more important parts, with more suggestions for the JEE Main to score very high in the JEE Main and JEE Advanced. All the best.